Welcome to our presentation. The title of our study is Health Discounting Survey, Measurement of Delayed Discounting of Dietary Options Associated with Weight. The authors of our study are Sebastian Garcia Zambrano, Mary Kate Shaughnessy, Riley Spriggs, and Courtney Wilson. Abstract. Discounting has been described temporally, probabilistically, and socially, and may have implications for health behaviors of at-risk populations. The purpose of the current investigation was to evaluate discounting of health choice behaviors of college students. This was accomplished by determining the effects of weight gain and length of diet on the selection of healthy, unhealthy food. Discounting surveys were developed and administered to 75 undergraduate students in which the questions evaluated the preferences based on weight change, length of diet, and diet. Linear, exponential, hyperbolic, and hyperboloid functions were fit to the data to provide a predictive model of participants' probabilistic discounting as it pertains to making healthy choices, and AUC values were compared with demographic variables. The results are reported and discussion is provided regarding potential contextual variables that may influence the health discounting behavior of college students. Introduction. One way to understand the choice behavior in individuals is called behavioral economics. This theory combines research from economics, learning theory, behavioral and cognitive psychology, and neuroscience to understand how people make choices among alternatives. Behavioral economics has been studied with health behaviors such as eating, physical activity, and obesity. Epstein and Salines 2000. Obesity is a major public health problem with its prevalence increasing in both children, Henley et al. 2004, and adults, Kosmarski et al. 1994. Behavioral economics provides an approach to understanding the unhealthy choices that individuals make. Delayed discounting is a measure of being driven by immediate gratification versus the willingness to wait for longer-term or delayed rewards of greater magnitude. Weller et al. 2008. Delayed discounting involves a choice of different magnitudes of the same reinforcer at different points in time. Reinforcers only available after the delay. Types of discounting is hyperbolic and hyperboloid. Our study will be using hyperbolic discounting. Hyperbolic discounting refers to the tendency to choose smaller, sooner rewards over larger, later rewards, when participants are offered a larger reward in exchange for waiting a set amount of time. People act less impulsively as the rewards tend to happen further in the future. In contrast, there's another type of function called hyperboloid functions. It is described as this equation. In this model, the v refers to the value of the reward, the a is the amount of the reward, v is the parameter that reflects the rate of discounting, x is the independent variable time until the reward is received, and s reflects the nonlinear scaling of amount of time. In order to calculate our rate of discounting after our experiment is complete, we use a method called area under the curve. In this method, all reward values are divided by the largest reward value, and all of the delays are divided by the largest delay. Higher AUC values represent a lower rate of discounting, and lower AUC values represent a higher rate of discounting. Purpose of the study. This study extends the results of a study conducted by Michelle 2014 and Reed and Van Leeuwen 1998 by incorporating multiple food items of different nutritional value. Thus, the purpose of our study was to evaluate the effects of weight change and diet length on the value of healthy and unhealthy food. Methods. The participants in our study consisted of 75 undergraduate students recruited from personal contacts of the experimenters. Participants included 10 males, 12.8% of the sample, and 68 females, which was 87.2% of the sample. Racial identification consisted of 68 white participants, 84.6% of the sample, 1 was African American, 1.3% of the sample, 3 were Asian, 3.8% of the sample, 5 were Hispanic or Latino, 6.4% of the sample, 1 was multiracial, 1.3% of the sample, and 2 identified as other, 2.6% of the sample. The average weight in pounds of the participants was 163, from a range of 90 to 280. The average height of the participants was 66.3 inches, from a range of 54 to 75 inches. The study was an online Google form. The materials were MyFitnessPal app in order to calculate the possible weight gain for consumption of unhealthy food, Google Forms in order to implement the online questionnaire, and SIU webmail in order to send the email request to the participants. Our procedure included 3 essential steps. First, a copy of the consent form was attached to the packet of survey materials. Participants were instructed to read the consent form prior to consenting participation. Next, participants completed a brief demographic survey asking them their gender, year in school, race, ethnicity, height, weight, and college major. The demographic survey was part 1 on the Google document survey. Lastly, participants completed in the health discounting survey, which was a 5-minute survey asking them to choose between 2 dietary choices with different corresponding delays, dietary options, and magnitudes. Appendix B. The survey was 36 questions and asked the participants to denote their preferences between eating foods from Menu A, unhealthy choices, McDonald's hamburger, McDonald's fries, Cheetos, milkshake, restaurant fajitas, associated with weight gain, or foods from Menu B, healthy alternatives, ground chicken, sweet potato, banana, protein powder, homemade fajitas, associated with no weight gain. The participants hypothetically had to select which food item menu they would prefer, given different time consumption and weight gain. The amount of days of consumption ranged from 1 to 6 days. The levels of unhealthy food were based on weight gain from 0 to 0.35 pounds per day. An example question is, would you rather choose to eat a food for 6 days and gain 0.3 pounds per day, or choose to eat B food for 6 days and gain 0 pounds? IOA. A second independent observer from Southern Illinois University's Behavior Analysis Therapy Program evaluated inter-observer agreement during 100% of sessions by calculating discounting statistics independent of the first observer. Inter-observer agreement was scored by trial IOA, or the percentage of agreement between the 2 observers on a trial-by-trial basis. It was calculated by dividing the number of trials in agreement by the total number of trials. Mean IOA for the intervention sessions were 100%. As you can see in our graph, the hyperbolic function best fits the data. This graph represents the average indifference point per pound value, or switch points, for each food scenario. Results. In a hypothetical situation, an average 29 students, 39% of the sample with a range of 37 to 26, prefer to eat unhealthy food for 1 to 6 days if there is not weight gain. In average, 16 participants, 22% of the sample with a range of 20 to 15, prefer to eat unhealthy food for 1 to 6 days if there is a weight increase of 0.15 pounds per day. In average, 15 students, which is 20% of the sample with a range of 18 to 14, prefer to eat unhealthy food for 1 to 6 days if there is a weight increase of 0.20 pounds per day. In average, 11 participants, 15% of the sample with a range of 14 to 10, prefer to eat unhealthy food for 1 to 6 days if there is a weight increase of 0.25 pounds per day. In average, 10 students, 13% of the sample with a range of 11 to 9, prefer to eat unhealthy food for 1 to 6 days if there is a weight increase of 0.3 pounds per day. In average, 10 participants, 13% of the sample with a range of 11 to 9, prefer to eat unhealthy food for 1 to 6 days if there is a weight increase of 0.35 pounds per day. These results suggest that if healthy behavior is considered to carry larger later health rewards, these results are consistent with the hyperbolic discounting of delayed health. Our results are consistent with a study by Reed and Lewin, 1998, whose results showed that when subjects were asked to pick between a healthy and unhealthy snack, in 1 week, and immediately the subjects chose healthy snacks more frequently when the choice was made in advance. There are a few limitations present within our study. The population used in the study was limited to only college students. In future studies, it would be beneficial to expand the population to different ages and populations. Another limitation in our study is that the survey was conducted online. This could have led to survey fatigue. As the participants were exposed to more questions, they could have just skimmed and not provided results concurrent with their previous choices. Participants in the study also tended to value avoidance of weight gain. This suggests that the participants were already at their preferred weight and were answering questions with avoidance of weight gain in mind. In order to avoid these limitations in future studies, the population chosen should be of different ages and demographics. The survey should be shortened and should be conducted in person to ensure validity of the data and lessen the chance of survey fatigue. To ensure that the participants are of different weights and sizes, it is important to have a larger group of participants in the study. Future research should also include treatment packages such as behavioral skills training and nutrition to ensure participants are well informed of their choices. To further extend the results of Michelle's study in 2014, future research should also compare the results of the participants' BMI to their discounting rates to assess their level of self-control and risk for obesity.